All right, so here's our second lesson for geometry for the year. Today we're going to be talking about angle measures and angle bisectors. So some of that you may kind of be able to make sense of just from the title, what we're going to talk about today. But specifically, we're going to talk about how to measure an angle. We're going to talk about how to name angles and some ways that angles are similar and different from line segments. Okay, so the first thing we want to talk about is what is an angle and how do we name that. So you can read this definition right here. You can pause the video and read the definition. And it says an angle is formed by two rays with the same endpoint. So remember, rays, that's kind of like a line segment. It's got an endpoint, but then it extends infinitely in one direction. So I can make a ray here, and I can make another ray. They have the same endpoint right here, E. I'll just use E for endpoint. And notice that when I do that, it creates this angle. An angle is like a measure of how far something is open. I kind of like to think about it like a book. How far are you opening the book? So there are different parts to an angle. So this common endpoint down here is called the vertex that we said. And then the rays create the sides of the angle. And it's not common that something is going to ask you, like, what are the sides of this angle? But at some point, you are going to want to see, especially later on, we're going to talk about when angles share sides. So you just kind of need to keep that in mind. So remember, that's what an angle is. So when we name angles, there are actually a few different ways to name angles. The best way is to name it with 3 letters. And we tend to use the 3 letters that we would use to draw the angle. So for example, let's add some more letters to our angle up here. I'll use AES. Shout out to elementary school. So think about if we were to trace along this angle up here. To draw the angle itself, I would either need to start on A or, let's change that. I would either need to start on A or on S, because if I started at E and I tried to like trace it without picking up my pencil, I wouldn't be able to draw the angle. So thinking about that then, one way to name this angle would be AES. And remember I told you mathematicians they're smart, they use good symbols, so they could say like symbol AES. This little symbol that they use kind of looks like an L, but think about it like an angle sign. It's like they're drawing a little angle before they name it. Another way to name this one would be angle SEA. Right, you could draw it backwards, starting with the S and going the other direction. And then the last way, sometimes you can name angles by just the vertex itself. So you could name this angle E. That's not always the best way, and we'll see why a little bit later, but just know that you may see it that way. All right, so I'll kind of skip for a second. If you want to try part B on your own, just think about what are some ways to name that. Pause the video, and then I'll give you some answers to see if you were on the right track. All right, so these are the answers that I have here. Notice that when you use 3 letters, the vertex always ends up in the middle because that's like the turning point for your angle, and it can't be anywhere else, or else you're going to be drawing a different angle, and we'll kind of talk about that tomorrow. So these are probably the first 2 that you got. You could have also said angle K. Angle 1 is another way to name that. Sometimes they put numbers. You may need to make a little note to yourself. That 1 right there is not the degree measure. So this is not like 1 degree of opening. They're just calling it angle 1. If you want me to be honest, I think that's a really dumb way to name angles, but sometimes you're going to see that throughout geometry, so I just want you to be aware. All right, and then if we go back to example A, this is another one that you probably need to get in your notes. Remember, we said that the vertex always ends up in the middle, which means Q is my vertex. So if I'm going to draw this angle, that means I'm going to be doing P to Q to R. And remember, angles have rays on them, so we need to have arrows at the end. Probably also best to make these specific points. All right, so just remember the vertex ends up being in the middle. All right, when we measure angles, we measure them in degrees, which I'm sure you've heard of so far. So degrees, that's just this little bubble right here. A degree is technically defined as 1/360th of a circle because there are 360 degrees in a circle. one thing that you probably do need to really make a note of here is when we write the measurement of angles, the measure of an angle is written as M with the angle symbol A. All right, so I'm looking right here, M, angle symbol A, or M. That means the measure of angle A or the measure of angle PQR. All right, it's different than just naming the angle because we're wanting to talk about its size. So to classify angles, you know these four basic ones. Acute is less than 90 degrees because it's so cute. Right angles, remember that right angles have the little box in the corner just to denote that they are right angles. Obtuse angles are all the way open, or not all the way open, but they're greater than 90, but less than 180 because 180 is when you're completely flat. We're going to call that a straight angle. If you're curious, there is an angle, I guess, technically past that, and it is called a reflex angle. And reflex is just when you're opening past 180 degrees, but you're not making a circle yet. So reflex would be something like that, right, where you're opening just greater than 180 degrees. Another thing I want to really make sure that you hear me say today, in geometry, you cannot trust what the picture looks like. I would put maybe a really big star next to that and put that in my notes. You cannot trust what the picture looks like. So even if it looks like a right angle, unless you see this box or something that tells us it's a right angle, it may not be one. They're always going to try to draw pictures to make you think that it's something, but unless we have the information, we don't know for sure. The same can be said for a straight angle. We don't know that it's a straight angle unless they tell us somehow that this is open to 180 degrees. So just be aware of that. Okay, so now we have two more kind of postulates and definitions to talk about. Both of these are kind of related to their counterparts in segment addition and segment bisectors. So try to remember what segment addition and segment bisectors were when we're talking about their applications to angles. So angle addition, remember segment addition meant I take two small pieces, and if I put them together, I'm going to create a larger piece. Well, angle addition is going to kind of say the same thing. If I take two smaller angles, so we can name this whatever we want to, A, B, C. So that's one small angle, and then I'll add another small angle in here. I'll make it bigger. All right, ABC and CBD. So I've got two small angles here, and when I add them together, they're going to create the larger angle. So these two small angles, that's the measure of angle ABC. Notice I'm talking about this angle right here, plus the measure of angle CBD. All right, that's this second angle, C. So trace if you need to, CBD, is going to create the larger angle, which is the measure of angle ABD. Notice when you put those together, you get this larger angle, the measure of angle ABD. That is called an angle addition postulate. Remember, postulate's just another word for like common sense rule. All right, so we want to make sure we have that one down. Angle bisectors, remember yesterday we said bisect is supposed to make us to think cut bi into two and two equal halves. So an angle bisector does exactly that. You may want to write that definition down. An angle bisector cuts an angle into two equal halves. So if I start with an angle, let's start with my angle XYZ here. If I want to cut that angle in half, I want to cut it into two smaller angle pieces that end up being exactly the same. So an angle bisector is a ray, generally, or a line. All right, so we're going to say, we'll call this BY for bisector. All right, so ray, we got to name this correctly, ray YB is an angle bisector. So that's going to mean that the two smaller angles that are left are going to be congruent. So that would mean that angle XYB, so follow that in your head or draw that out, XYB, is congruent to angle BYZ. All right, so now these two angles are congruent. Now the last thing I just want to make a note of for you is that notice on the angle bisector, I used one arc, like one little arch or arc, however you want to say that, on each angle. That denotes that they're congruent, the same way that the little tick marks on segments denotes that they're congruent. For angle addition, I don't know that these two pieces are congruent. I just know that they're both smaller pieces that come together to create a larger angle. So because I don't know that they're different, on one angle I used a single arc, and on the other angle I used a double arc to denote that they may have different measurements, or that they do specifically have different measurements. All right, so make sure you have all of those in your notes. You need to have all pictures drawn out, all definitions written out, any examples that we did, and we will work on some problems together tomorrow.